Classify the triangular shape of the support beams in the diagram by its sides and by measuring its angles. To classify a triangle by its sides, you first need to determine the number of congruent sides. In the given diagram, there are no tick marks to indicate that any of the sides are congruent. So, there are no congruent sides. Therefore, because there are no congruent sides, this triangle is a scalene triangle. Next, to classify a triangle by its angles, you first need to measure its angles. One of the angles in the given triangle is marked with the right angle symbol. So, this triangle has one right angle with a measure of 90 degrees. Next, when you measure the bottom angle in the triangle, you find that its measure is 35 degrees. Finally, when you measure the third angle in the triangle, you find that its measure is 55 degrees. Now, this triangle has one right angle and two acute angles. So, because it has one right angle, this triangle is a right triangle. Therefore, you can classify this triangle as a scalene right triangle. Classify triangle ABC by its sides. Then determine whether it is a right triangle. To classify triangle ABC by its sides, you first need to find the length of each side in order to determine if any of the sides are congruent. You can find the length of each side using the distance formula. To find the length of side AB, let x1 equal 0, y1 equal 3, x2 equal 7, and y2 equal 1. You can substitute these numbers into the distance formula. When you simplify, 7 minus 0, quantity squared, gives you 49, and 1 minus 3, quantity squared, gives you 4. 49 plus 4 gives you 53. So, the length of side AB is equal to the square root of 53, which is approximately equal to 7 3/10. To find the length of side AC, let x1 equal 0, y1 equal 3, x2 equal 1, and y2 equal -1. You can substitute these values into the distance formula. When you simplify, 1 minus 0 quantity squared gives you 1, and -1 minus 3 quantity squared gives you 16. 1 plus 16 gives you 17. So, the length of side AC is equal to the square root of 17, which is approximately equal to 4 1/10. To find the length of side BC, let x1 equal 7, y1 equal 1, x2 equal 1, and y2 equal -1. You can substitute these values into the distance formula. When you simplify, 1 minus 7 quantity squared gives you 36, and negative 1 minus 1 quantity squared gives you 4. 36 plus 4 gives you 40. So the length of side BC is equal to the square root of 40, which is approximately equal to 6 3/10. Now, as you can see, none of the side lengths are equal. So there are no congruent sides. Therefore, triangle ABC is a scalene triangle. Now, to determine whether triangle ABC is a right triangle, you need to check for right angles. If triangle ABC has a right angle, then two of its sides will be perpendicular to each other, and the slopes of those two sides will have a product of -1. So, you need to find the slope of each side of the triangle. You can find the slope of each side using the slope formula. To find the slope of side AB, let x1 equal 0, y1 equal 3, x2 equal 7, and y2 equal 1. You can substitute these values into the slope formula. When you simplify, 1 minus 3 gives you -2 in the numerator, and 7 minus 0 gives you 7 in the denominator. So the slope of side AB is equal to -2/7. To find the slope of side AC, let x1 equal 0, y1 equal 3, x2 equal 1, and y2 equal -1. You can substitute these values into the slope formula. When you simplify, -1 minus 3 gives you -4 in the numerator, and 1 minus 0 gives you 1 in the denominator. -4 divided by 1 gives you -4. So the slope of side AC is -4. To find the slope of side BC, let x1 equal 7, y1 equal 1, x2 equal 1, and y2 equal -1. You can substitute these values into the slope formula. When you simplify, -1 minus 1 gives you -2 in the numerator, and 1 minus 7 gives you -6 in the denominator. -2 divided by -6 gives you 1/3. So the slope of side BC equals 1/3. Now, as you can see, no two slopes have a product of -1. So, no sides are perpendicular to each other, and there are no right angles. Therefore, all three angles in triangle ABC are acute angles, and you can classify triangle ABC as an acute scalene triangle. Find the measure of angle PQS. To find the measure of angle PQS, you first need to find the value of x. To do this, you can use the exterior angle theorem, which states that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. So, in the given diagram, 3x plus 25 degrees must equal 2x degrees plus 65 degrees. Now, to solve for x, you can first subtract 2x from both sides of the equation. This gives you x plus 25 equals 65. Next, you can subtract 25 from both sides of the equation. This gives you x equals 40. So, the value of x is 40. Now, from the diagram, the measure of angle PQS is equal to 3x plus 25 degrees. You found the value of x to be 40, so you can substitute this value in for x. When you simplify, 3 times 40 gives you 120, and 120 plus 25 gives you 145. Therefore, the measure of angle PQS is 145 degrees. The measure of one acute angle of a right triangle is 1 5/10 times the measure of the other acute angle. Find the measure of each acute angle. To begin this problem, first draw a diagram of the situation. You are told that the triangle is a right triangle. You can label the measure of one acute angle as x degrees, and because the measure of the second acute angle is 1 5/10 times the measure of the first acute angle, you can label the measure of the second acute angle as 1 5/10 x degrees. Now, to find the measure of each acute angle, you first need to find the value of x. To do this, you can use the corollary to the triangle sum theorem, which states that the angles of a right triangle are complementary, meaning their measures have a sum of 90 degrees. Because the triangle in this problem is a right triangle, you can apply this corollary. So, by the corollary to the triangle sum theorem, x degrees plus 1 5/10 x degrees must equal 90 degrees. To solve for x, you can first combine like terms on the left-hand side of the equation. X plus 1 5/10 x gives you 2 5/10 x. Next, you can divide both sides of the equation by 2 5/10. This gives you x equals 36. So, the value of x is 36. Now, from the diagram, the measure of one acute angle is x degrees. You found the value of x to be 36. So, the measure of one acute angle is 36 degrees. Next, the measure of the second acute angle is 1 5/10 x degrees. When you substitute 36 in for x and simplify, 1 5/10 times 36 gives you 54. So, the measure of the second acute angle is 54 degrees. Therefore, the measures of the acute angles are 36 degrees and 54 degrees.